Hi everybody. What I want to talk about today is this concept of stoichiometry. And basically what stoichiometry is a concept in chemistry that really equates how much material is reacting in a given chemical reaction. So anytime we need to go from one part of a reaction to another part of a reaction, we're going to use stoichiometry. So if we start to look at something, a chemical reaction of some sort, let's say we're looking at the reaction of zinc metal with hydrochloric acid to produce zinc chloride, which dissolves, and hydrogen gas. Absolutely doesn't matter which reaction we're talking about. This is just an example. The first thing we need to do before we can start thinking about stoichiometry is to balance our reaction. Make sure we're starting with a balanced reaction. In this case, zinc is already balanced. I notice a problem when I get to the hydrogen and the chloride. And if I just put a 2 here to the left, I get now everything balanced nicely. So what does this tell me? Well, this reaction tells me that one zinc atom here will react with 2 molecules of HCl and will produce 1 dissolved molecule of zinc chloride and 1 gaseous molecule of hydrogen gas. The molecule level or scale isn't particularly useful for us when we start talking about measuring things, because obviously we don't have any balances or devices that can measure down to the molecule size or to the atom size. And so we scale everything up using that mole unit that we've learned about. And remember that this also can mean, if we scale everything up by Avogadro's number, this can mean that 1 mole of zinc atoms can react with 2 moles of HCl molecules to produce 1 mole of zinc chloride molecules and 1 mole of hydrogen gas molecules. We're just scaling everything up by that factor of 6.02 times 10 to the 23rd. Stoichiometry is sort of expressing this concept that for a given chemical reaction, the pieces always react together in the same fixed ratio. We have 1 part zinc reacting with 2 parts HCl to produce 1 part zinc chloride and 1 part hydrogen gas. And so when we talk about stoichiometry problems, those are going to be any problem where we're given some amount of a starting material or of a product. We're given some amount of one term in a reaction, and we're asked to calculate how much that represents in another term of the reaction. So for instance, in this reaction, if I said I was going to use 10 grams of zinc, and I wanted to know how many grams of hydrogen I was going to produce, that's a stoichiometry question. I know the ratio, but that ratio is in counting numbers. It's in atoms and molecules or moles. It's not in masses. And so a stoichiometry problem will always encompass 3 steps. Step 1 of a stoichiometry problem is always going to be to convert your starting amount, whether that's in grams or molecules or milliliters or liters of a gas, whatever it is, convert that starting amount to moles. Secondly, we'll use the mole ratio from the balanced chemical reaction to go from point A to point B. In this case, I would say that mole ratio would be 1 mole of zinc to 1 mole of hydrogen gas. And then thirdly is the step I like to call answer the question. So we'll convert now that new mole number that we get into whatever desired unit we have. So if the problem is asking us about how many, as in this example, how many grams of hydrogen, then step 3 would convert from moles of hydrogen to grams of hydrogen. If it was asking about liters of gas, I would use a different conversion factor. If it was asking about molecules, I would use a different conversion factor yet. And so what we want to think about is that mole-to-mole ratio that we get from our balanced equation, our balanced chemical reaction, is really central to stoichiometry. And we're going to get into and out of that in different ways. So one that's very common and is usually the first one introduced is when we talk about converting from mass. We can convert from mass to moles using molecular weight or formula weight or molar mass, whatever you want to call it. That number has units of grams per mole. We're going to get that from the periodic table, adding up the pieces of our chemical. We also have the ability to convert to moles from atoms or molecules. That's usually the second type of conversion that's presented in an intro chemistry setting, and this is going to be using Avogadro's number. That's at 6.02 times 10 to the 23rd, and the units on that are some sort of a counting item, atoms or molecules, per mole. So if we're given in step 1 an amount in atoms or molecules, or if we're asked in step 3 to present or to calculate an answer in atoms or molecules, we're going to need to use Avogadro's number. The other two conversions that we can think about using are when we talk about how much of a solution. This is a little bit of a special application and is usually presented at the end of a course, but the concentration of a solution is going to be our conversion factor here. And this could have a myriad of different units, but it's going to be some amount of material per some volume of solution. So it could be something like grams per liter, or it could even be in moles per liter, or a unit that chemists call molarity. And the fourth type of conversion that we could have here is for volume of a gas. This is presented in the gases chapter, and we have two options here. If that gas is contained at what we call standard temperature and pressure, it's sort of the easiest way to think about it. We have a special conversion for that there are 22.4 liters of gas per every mole of that gas. And if that's not the case, we can use our ideal gas law, which is expressed as PV equals nRT, to relate the volume of a gas V to the number of moles of that gas N. So all four of those options allow us to convert from some other unit to a mole-to-mole ratio. And so in this case, the particular example that we have on the page here, I'm starting with a mass. That's my 10 grams of zinc. And so I would go over here and say 10 grams of zinc is my starting material. I need to first convert from mass to moles, which means my grams of zinc has to go on the bottom, moles of zinc on the top, and I'm going to get that number from the periodic table. That's just the molar mass of zinc. My next step is going to have to be the mole ratio. So I need moles of zinc on the bottom, so it cancels out here, and moles of the thing I'm asking about, in this case hydrogen, on the top. That's going to come from the balanced chemical reaction. And in this case, when I look at my balance, I have 1 mole of zinc reacting to give 1 mole of hydrogen. Now, even though this particular number, of course, 1 over 1 is a mathematically insignificant calculation, it's still important to write it so that we can see that unit changing. And then in step 3, we're going to answer the question. So we'll get rid of our moles of hydrogen that we just calculated. And this question is asking me how many grams of hydrogen I'm going to produce. So in this particular example, step 1 and step 3 are both a mass to moles conversion. Both of those numbers are going to come from the periodic table. So when I look at this and I start to fill in my numbers, I'm going to say this is from the periodic table, this is from the periodic table, and my step 2 is from the balanced chemical reaction. When I look at the table, zinc, every 1 mole, 65.39 grams. My mole ratio I've already filled in, 1 to 1. And hydrogen, every 1 mole is 2.02 grams. Don't forget that because the molecule is actually H2, we need to have that 2.02, not just the 1.01 from the periodic table, because I have 2 hydrogens represented in every molecule. So mathematically here, I'll take my 10 grams of zinc to start with, and when I divide by 65.39, I'll end up with a unit of moles of zinc. And then I go on and multiply and divide both by 1 in the next step. That changes my unit to moles of hydrogen. And then when I multiply by 2.02 at the end, moles of hydrogen cancels, and I end up with grams of hydrogen. And so my answer here at the very end, I come out with 0.3089 and some more numbers, the unit grams of hydrogen. And I always want to make sure I round to the appropriate level of significance. So my starting number was 10.0. That's 3 significant figures. So I'll round this to 0.309 grams of hydrogen. So what I know then based on this is if I start with 10 grams of zinc and enough hydrochloric acid to dissolve it all, I'll produce about 0.3 grams of hydrogen gas. This is a classic stoichiometry problem. You'll use the same 3-step method anytime you're starting with one amount of a chemical and asking about a different chemical in the chemical reaction. And again, using our little diagram at the right, we can start or end in either mass units, atoms or molecules, volume of a solution, or volume of a gas. And the only thing that changes is where we get our conversion factors. You'll get lots and lots of practice with this.